Hi, so my name is Eitan Shapiro, and I'm the developer manager of Videocites. So we're going to talk today about Redis and RediSearch in specific, and I will describe to you how Videocites built its solution over those technologies. So Videocites is building the first generation of search engines. Everybody knows about text search, everybody's searching Google. Everybody knows about audio search like Shazam. And everybody knows that there is image search. You can go to Google and any image, you can find its duplications. Videocites is building the next generation for video by video search. Now, what do I mean by video by video? It means that you actually give a full video as a query to your system, and then you can get back all the duplications of that video. And that's done across all the videos that are available across platforms. And that's, for the content owner, that's give the possibility to track the data, to track their content, and also monetize it better. Regarding the technology, so it's based on fingerprinting technology, a novel technology that is patent protected. We take the video with all its frames, and each frame is being fingerprinted to a very small hash code of 32 bits. That's allow us, for example, you can see the numbers here. For example, we can take 1 million terabyte of video and actually transform it only to a 4 terabyte database. And on that database, we can do pretty fast search, and we can do or full matches of video or partial matches of any duplications of your original video. So some more information about the problem. As you can see on YouTube, here an example. We can see a video from Katy Perry that got more than 100 million views on the official video. But then that video had almost 40,000 duplications. And on those duplications, there were almost 700 million views, which is lost money for YouTube and for the content owner. Now, outside of YouTube, there actually, the other platforms doesn't have any video search capabilities. And just a bit about more numbers, 72% of the top rated videos on Facebook are actually duplications, are not embedded from YouTube. So about the solution. So Videocites is building a system that allows the content owner to find their content and all the duplications. Because we're a third party, we can actually handle all the different content platforms, as you can see. And the technology is based on deep machine learning. And that learning allows us to handle different video characteristics and manipulations. You can see some examples here at the bottom. So video can have different ratios. It can have different subtitles on the video. It can be flipped. And, of course, different resolutions, etc. So the conclusion is that through the system, the content owners can regain control. They can increase the monetization of their videos. And also they can do analytics. They can get all the copies with the meta across the different platforms and analyze based on their needs. Okay, moving to describe the architecture. So on one side, we have the content platforms. We're fetching all the videos, and we're fingerprinting the videos. The process is very, very fast. Then we store all the fingerprinted videos into Redis, and the metadata into additional database for the analytics. The other part of the system is, of course, the search. So the user, the content owner, can supply any video, and that video is going to be fingerprinted in the same method that we done on the other side, and a query will be sent to the search engine, and the results will be collected, presented in the dashboard with all the relevant metadata, and then now the content owner can take actions. For example, to ask the duplication to be removed, and other examples. Okay, so let's get to the technical part. So the question is, how can we map a video search to a textual search that we can use a search module like RediSearch? So if you think about it, we take the video, we take the frames, we create hash codes, and we actually get a list of hash codes, which can be considered like a text document. Each hash code is a term with a clear position in the document. Once we're done that, we can build an inverted index. So you can see an example of frames on the left side. Each frame is mapped to a hash code, a 32-bit. And then each code is holding all the videos that hold that code in them, the same way with text documents. So if we build inverted index, here you have an example. So this is the output from the statistical or info of RediSearch. So we can see here an example. It's pretty small database. We have 2.6 million videos in this database. And we can see, so the number you can see here below in the doc ID counter, we can see the number, the 2.6 million. And if we look for the total memory usage, we can see it around here. So it's almost 4 GB for the whole index. From the structure itself, it's pretty simple, only 2 fields. We have the H field, which it's the hash codes, and some date filter. So as you can see, the index is pretty effective, and this allows to build with one database, hold really tens of millions of videos in one database and get a very fast search. So just to see more details on the query side, so we take the hash codes of the video we want to search, and we expand the hash code, so we don't search only those numbers. We actually expand the query also based on some logical synonyms, and we send the query just to show you how the query looks. So it doesn't look like a usual text search, right? Text search is 3 terms in general or usually, and here actually you have a very big query, hundreds of terms. The terms are numbers, and it's a Boolean query where we have or of the synonyms and between the different hash codes. So pretty nice to see how RediSearch handles a very, very large query. And I know in Lucene, for example, those queries become pretty slow. So it's pretty amazing. Okay, some more information why RediSearch is a great fit for the problem we're solving. So as we scale, everybody knows we need to start sharding. As you shard, in our case, we want to shard by the video ID because any shard that we search needs to be consistent with all the information of the video. Now, in Redis, the sharding is usually, because it's a key value database, then the sharding is by the keys. But actually, when you create an inverted index, the keys are the terms, and the values are the video IDs. But we want to shard by the video IDs. So luckily, RediSearch is in a natural way, is sharding by the video IDs, so it's a great fit for the problem we're solving. Another feature that was mentioned also earlier today is the numeric filter. We have metadata on our videos that are numeric, and with RediSearch, we can speed up the search by filtering the videos that are not relevant based on that numeric or date filter. Some more information how we're using RediSearch. So a key feature in any search engine is to sort by relevance. Now, when it comes to video search, the relevance is by hash code differences. So RediSearch has 2 features that were developed for us in the RediSearch. The first one is the ability to expand the query. So actually, we don't need to expand all the synonyms on the client side. We can send the query, and on the server side, on the Redis server, to get the query blown up to all the synonyms, which becomes pretty large. And then what we want to do is to write a custom function for the scoring. So we need to, we're able with this feature to actually write code that runs on the Redis server and can sort the videos by the relevance. And this allows, again, to speed up the whole search process and also cut off all the videos that got very low score, and we don't need to process them as part of the search. Another topic outside of RediSearch is actually the SSD over Redis, or Redis over SSD, sorry, which was mentioned also earlier. So in addition to the index, we also hold all the video fingerprints object for doing the search. And just for numbers, this one is growing around 50 gigabyte every month. So the Redis over SSD allows us to really optimize between the data that we need, the speed, and also the cost of holding that information in memory or on the disk. So let's see. Okay, so here our SSD, and Redis allows us to pull the fingerprinting videos into memory, but we can do it in a lazy way. We can do it only when we need the object, only at the search time. And then we have a multi-process engine that can read the different objects from memory and process them. And what we're doing by doing some prefetching, we can prefetch the videos that the engine is going to consume. So there's no actually any delay in the process, but we don't need to hold all those objects in memory all the time, only when we need them. So again, we're getting much more from a single machine. We can handle more videos, more searches with smaller machines. To describe a bit the process, the work that the collaboration we had with Redis Labs. So first of all, as I mentioned, as we worked on RediSearch, they developed new features like the custom scoring. As we developed, we have everything automated, so we have unit tests, and we got a library that allow you to create disposable Redis servers. So the Redis Lite library that a lot of people use doesn't work with Redis 4.0, and of course not with the new modules. So this library allows you to create actual servers that are disposable as you run your unit tests, and it's based on the port. The last thing, as we had to roll out the solution, and we rolled out to production, some bugs were found, but the turnaround was pretty fast, and we were able to go to production in a very short period of time. Okay, some future challenges that we're going to handle. So as we scale, we'll need RediSearch to work in a cluster mode. And specifically in cluster mode, when we search, usually when you search, you get only the top results, but actually we get all the results and we process all the results from the first one until the end one. So as you move to cluster and scale, we need that to still work in effective manner. Down the line, of course, we'll need this solution to have high availability and disaster recovery, which was mentioned, but we'll need that for the search module. And another area is the loading of Redis from a backup. So as we index more and more videos, some videos that are older, we don't want to hold the database up and running. We want to shut them down and be able to run them only by a need. So we need the Redis to be able to come up pretty quickly from a backup. But when those backups are pretty large, hundreds of gigabytes, then this process could be a bit slow. So it's another future challenge we'll need to handle. So thank you. And Videocites is hiring, so you have some information here below, and you can talk to me after the lecture.